Hello, everybody. How are you all doing today? Sorry, that's Active Fireball's intro. Hello, everybody. This is That Programming Guy, and remember, you guys can do the thing no matter what you're doing, no matter what's going on. You guys can get it done. I believe in all of you. So, how are you all doing today? Today is Sunday, which means yesterday was Haskell. Today is some 68K assembler. Y'all excited? Because I'm excited, motherfuckers. Alright. So yeah, we have to do this. Oh, guys, you're the best. Alright, so what did we get done last episode? Last episode, I don't remember because that was 2 weeks ago. We've got to add. We get this. If the source is the immediate, then we convert it to that. Yes, thank you. Otherwise, the source is not immediate, and we have to get that. Get addressing mode. Okay, it's effective address. Test for all addressing modes. Oh, yes, we have to get the addressment. Okay, so I'm trying to remember. Where I started. Even with 2 weeks. Even just with 2 weeks of not actually coding, I'm like, oh god, what am I doing? Alright, add instruction, OP size, source, destination, convert to binary. Oh my god. If the source is the data register, yes, if source is data register. So we have add byte byte, add byte. And from there we have, it's either EA, DN, or DN, EA. Yes. Working on some adds. If the source is the data register, like this one, then we can binary.append, convert EA. Otherwise, we have to convert or source EA, which is if the source is the immediate number. So if I do something like #2, this gets that. And then otherwise, we need to deal with this. So if we go to add, I guess we can do anything now, but let's just go to add anyway, because that's what I've been using. That's what I'm used to. There's one called bra. That's awesome. I wonder if that stands what that's for. Come on, let's get to add. And add. Here we are. Wonderful. So basically, we need to go, if it's EA, I could do something like, 56 A3. I could do something like that. Oh my god, guys, if you don't have any coffee, you should let coffee into your life. So get addressing mode. Use the instruction parts 0, 1, 2. Makes sense. Lowercase effective address. Test for all address modes that don't start with a hash. Yes. So we get 1.8. So if it's this case, we would get a this. This would return, set the register to this. So we'd return EA, and we get this addressing mode. Cool. So once we have, I guess I should have looked at my last episode and been like, yo, here's what we're gonna do. I'm a dumbass. Whatever. Oh my god, guys, it's a lazy Sunday today. It's a very lazy Sunday today. I just want to let you know that. Alright. So now we have the effective address. So now we need to write down. So we have the first word is just the instruction. So if you look at add, I'm not muted, am I? No, I'm not. Okay, good. If you look at add, we have this. So, what is the effective address of this one? What effective address is this? EA, DN, or add DNEA. Because is this the effective address of this EA or just the source? Because now I'm confused. I mean, I am making my own. I am making the emulator as well, so I can do whatever I want in the first place, and it doesn't matter. The DN mode is used when the destination is a data register. The destination EA mode is invalid for the data register. So yeah, what's this effective address? Unless all of it just goes into one, but it's like, well, I mean, I bet I actually answered this question on a previous episode that I did, but I can't remember for the life of me what that was. So we have the effective address, which is this EA right here, right? And this EA could be an in meeting, it could be something else, the op mode, and then the register of, probably this is just the register of the data register. That's probably what it is. But now here's the thing, all right? Let's say if I have EADN or DNEA, how do I tell the emulator this is what it should be using or be doing? So, I get it. So register and mode, this is just, since, I think basically what it is, since there is an effective address in if the source or destination is the effective address, it's just right here with the op mode, with the register, and the register is the register of the data register. I think that's what it is. So I think I've been going a bit too hard on this, and so the only words after this instruction format is the words that we have with this, that. So I think so. So basically, this is the EA. So basically, we have 1101. We have the DN register. We have the op mode. Then yeah, we have the EA mode, then the EA register. All right, so yeah, I think I've been putting a bit too much work into this. So we have convert to binary. We split on the instructions parts. If instruction part source, 0 starts with the D, then source is the data register. If it is, okay, so let's comment that out for right now. Okay, I think we're good so far. Oh my god, guys. I've been researching a PC to make, and it's been really fun to do. Alright, so I got this, though. If is source data register, God, NewbieDemos would be like, why the fuck do you have so many words? If source is data register, do that. Save. If the source is data register, then we want to get the EA string. So I actually have this of string effective address as binary. String empty, and then we have string data register as binary. String empty. There we go. I think this is good so far. Hello! Hello! Cortorin, there will be Haskell. I do Haskell on Saturdays, and I do 68K programming on Sundays. So since you're new, let me explain to you the story of why I'm doing this. So if you remember from yesterday, I was talking about the maze generator and how I want to make it in Haskell. Well, I also want to make one with the Sega Genesis. because I really like the Sega Genesis. I think it's cool. So I want to program for the Sega Genesis. The Sega Genesis uses a Motorola 68000 processor. So in order to program for the Sega Genesis, I need to program in 68K assembly language. However, I don't know assembly. I've never programmed in assembly before. I think it's really cool to learn how to program in assembly. So instead of going, let me get the manual and learn how to program in assembly and do something, instead of going this way, I went that way. All the way to the wall. I'm like, you know what? The best way for me, not the best way for me to learn this language, but a fun way to learn it would be to make my own assembler and emulator. So, once I make my own assembler and emulator, then I'll go back to my Sega Genesis programming with the knowledge I've gained from writing 68K assembly by writing the assembler and emulator to make the maze generator in a Sega Genesis game. So that's my idea. So, yeah. Yes, higher level Haskell to low level assembly. Kind of, it's C#, but it's C# to read assembly language, but I'll eventually have to write the assembly to test to make sure what I have. But yeah, so yeah, that's it. So yeah, it's a free fall. So where I am right now is when I encounter an instruction like add, it takes that mnemonic. So add a byte, this number to this data register. Do something like that. That's what it does. Well, that has to obviously translate it to binary and write to a file. And then the emulator will read the binary and will just keep reading those bits and go, okay, I know what I need to read. Read this. Okay, now do something. So I've been working on the add instruction because it just seems the simplest to me. It might not be the one to start with. But a lot of the previous episodes, I'm on episode 12, a lot of the previous episodes have been about me kind of understanding, taking this and moving it to binary format. And I'm still struggling with I should do what they say versus I'm writing the damn thing in the first place. I'm going to write my own emulator. So it really doesn't matter if I'm correct or not with what Motorola wants me to do. So it's interesting. So we're working on the add instruction. So right now we have basically, and I changed it a little bit. So if I open up me some Notepad++ here. Hey, look, Haskell. For example, if I write instruct, usually I'm going to change the syntax around it, because usually you go add.b to say you're adding a byte, and then you do pound, I don't know, whatever number you want, and then the data register you want to add it to. Very simple. I'm going to change a little bit to go, I'm going to go add byte. I'm going to actually say byte, and I'm going to keep the immediate as in this number, and then a D5, whatever, D4. So right now I'm kind of translating this, and it needs to go into a binary format to match this. And so the 68K bases on words. Oh, no. I can use all C#. This is just me written in C#. And the reason why I chose C# was because I main C#. So I can use whatever one in C#. I'm going to try to make it as close as possible. Basically, I want to just emulate how it works. But at the same time, though, if we go somewhere, there's actually like a graph of how all the parts of the processor fit together. So I'll try to do that. But right now, it's just really the base thing is... yeah, I know what you're thinking. Yeah, I do have some string builders. I do. I promise I have them. I do have some string builders. But right now, it's just to make it work. You know I can make this go so much more faster. I could, be making it fancied. Whatever. I don't care. I just want to make it work. That's what I want to do. And I know there are some people out in this world who would go, no, it has to be perfect when you first do it. And that's fine. But for me, I've done programming enough. I'm like, I just want it to work. So I'm going to make it work right now. And if right now it's going to be using string string interpolations or string builders, that's fine. As long as it works, and then I can, if I want to, then I can try to make it faster. But thanks for joining me. So yeah, so basically, so now we have, all right, so if the source is the data register, great. If the source is the data register, we want to get the data register as binary. We want to convert destination EA. What does this do? No. Okay, that's great. That's fine. What I need to do here is I need to read the data register. So this would be add byte. This would be D5, and then we have an EA. All right, so this would be D5. So this is 0, 1, 2. So source 0, 1, 2. Hey, source. We would need to read the source, and then we need to get the register out of it. So this would be the effective address. We would need to call combine no, this is not the one I need. Addressing modes. And also a lot of this has been building up all the objects, because oh my god, object-oriented programming is so great. I can't imagine trying to do this in Haskell right now. I couldn't. Alright. Yes, get addressing mode, effective address. I need to do this, even though this is bad right now. No, I need to mode. No, fuck. Wait, what? Why isn't this? Should totally be a static method. This should totally be a static method. Should be a static method. Why should I use tuples? I like my objects. I see what I was doing. All right, whatever. I'll just deal with this. I'll just deal with what I have right now. I'll change it later. Although, it would seem better to... I don't know. Because, I really might want to make this as a static method instead. I like that idea, making it static. Let's make this static, bitches. Come on, Visual Studio, you can do this. There we go. Static. Here we go. Awesome. I like this so much more. Well, hold on. So I did it originally so I can make it once, and I wouldn't have to rebuild. No, this is fine. I'm fine. We'll do this. This is going to be fun. This is going to be fun. We'll see if this works. I don't know. It might work. It may not work. Source. There we go. All right. So now we have the data register. So now we need to append the binary. So again, why? God damn it. Conversion data registry binary. I believe that's it. What do I want? Oh, I need an int. Oh, I need to convert this to an integer. Oh, okay. Oh my god, this is gonna be just fucking great. I need to convert to int 32. So many conversions. As I said, like, there's so many conversions in here. I know there are so many conversions. This will be so much more better when there are no conversions. Fuck it, I'm just gonna make it work right now. It is cold as balls in here. Not really, but still. You know what's really weird? That programming guy, based the channel you're watching right now, from streaming for what, a month and a half, is actually doing better than my gaming channel right now. It's not ahead of my gaming channel. No, my gaming channel has 51 followers. But I'm gaining a lot of followers for that programming guy. I'm also getting the average of viewers too. My god, getting average viewers for games or gaming is hard. Alright, so if the source is the data register, we want to do that. And then we want to get the effective address. Okay, so no, I might not keep that right now, but okay. So we have instruction parts destination. So now we have EA, and we need to convert that. So we need to do this. So we have that. And it's the same thing. So now we need to append in what order? It needs to be in mode and then the register. So we need to go. Oh my god. How do I do the modes again? Well, that's going to change everything. There we go. Change that. Set. I see. We set the register, and I see. We get the addressing mode. Okay, I get it. So we had this is the mode. Yeah, we passed the mode. Okay, so we get the mode, and then we do have to convert it again. So we have this. Oh my god, I'm gonna totally need some. Okay, so I'll add those later. When I'm done with this if statement, I'll totally change this to string builder, since I know those are so much better than trying to manipulate mutable strings. Oh, this is EA. Oh, wait. Hold on. Hold on. What did I do here? I forgot. God damn it, me. Um, Dressing modes. Oh, yeah, I do set the register because I do actually go get the register. Oh, I do it here. I don't have to do it here, guys. Oh, look, I'm so smart. I already watched out for myself. Awesome. That's great. Okay. Okay. That. Okay. So if the source is the data register, I just need to look at the source. It's not. Okay, so I bet these can be taken out of the if else. I bet I can not extrapolate, that's where take some of these things out of the if, but not right now. Okay, so if the source is the data register, we get the addressing mode of the data register, which is the source. And then we get the effective address. Basically, we look at the destination. Otherwise, these would be switched. But I'm not going to worry about it. And I'll just get the first one. So now we have the effective address. So now this works for... Cool. Oh! I am the biggest dumbass in the world. Okay, you know what I can do? I can do this. Oh, how do they define it? How do they define the addressing modes? How do they define that? Come on. There we go. Effective addressing modes. Alright, how do they say the thing? It's the operand length. Operand length. Although I will need to the displacement. That's the word I'm looking for. Okay, so this displacement. Displacement. There we go. Then we'll have a... Why is there so many? There we go. That's better. This can go away. I don't need that right now, but I will probably later in the future, but I won't right now. Public void get displacement. String. Displacement. All right. Okay. Oh my god, guys, that's some good coffee right there. Guys, coffee's great. Let coffee into your life. Okay, so now we have that. So now, from here, we can also get the displacement. as a binary number. Wait, what? What is all this? This is what? Convert instruction to binary. What was I working on? Convert to binary. Oh, okay. Did I just not? Okay, we're just going to get rid of this right now. We're going to comment that out because I don't know if we need that right now. I don't think we do. All right. All right, so we get the displacement. So an integer, that's a 16-bit. So if you look at addressing modes, we're going to have to this, right? And we're going to have to have EA dot, I need a set displacement. Oh, my bad. This is void. There we go. Okay, so we have that. So now we can set the displacement to this D16. Right. 0 is a string. So we have a D16. So it's a 16-bit integer. How would that come in the syntax? That'd just be like add long. This would be 16 bits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 2 bytes. 2 bytes. So like what, 7,000? A5. So now I need to get this, which is the displacement. So I need to, 0 will be an integer. And I need to convert that integer to a 16-bit number. So, oh, how was I doing it here? What was I using? Come on, what was I using? Yeah, I'll change. Convert dot to string. I see. Convert dot to string. Int displacement equals convert dot to int 16. Address parts 0. There we go. EA dot set displacement with convert dot to string displacement 2. There we go. All right, so now we have a get the integer, which is the displacement, and set it. So now we have the displacement as a 16-bit integer, which is great. We have to do the same thing here, which I totally forgot to change. So we have effective address EA equals addressing modes equals. We want to get that because we have to set this again. With that, we have EA dot. Come on. Does PC have its own? D16 PC? Yeah, it has its own reg. Okay, so that's fine. So we just need to get. I'm assuming it's the displacement. I'm assuming they call it a displacement when you involve the program counter. Yeah, it's called the displacement. Awesome. So we get the displacement. We're going to just do this. There we go. All right, so now we have that. Okay. That's the PC. We have to do the same thing with this one, but the D8 ANXN has, it's a displacement and something else. So let's try to find that one so we can get this done. Nope. Keep going, Darren. Keep going, that programming guy. You can do this. Really? Is that the one I was looking at? Add. Yeah, so if we have, we're looking at D8 ANXN, and we have D8 PC, which is the program counter, and XN, which is 110, and then mode on this one is uno, uno, uno. Okay, so we have to go back to the addressing modes, which I don't know where they put it. That's fine. We are going that one. Yeah. Oh, the syntax looks like that, huh? Oh, generation, that's a syntax. Okay. All right. Okay, so we have the displacement, and we have the index register, and we have the scale and the size. This will be fun. Okay. So displacement, I can do that. It's an 8-bit integer. So let's get the displacement first. This is simple enough. So we have a byte displacement is equal to convert dot to byte effective address parts 0 ea dot set displacement of convert dot to string displacement 2. There we go. And now we have to do the same thing with, so that's D8. We have to do the same thing here. Go me, okay. So with the program counter, all right, so now we have the index that we need to get as well. So the index is in 3, but the index also has a size and a scale. So we are looking at D8 AN XN dot size multiplied by scale. Index registers a fat. Contents the address register plus the displacement plus the index register. Oh, I get it. I understand. I totally get it. This is like it is. Okay, this is not this. This is, so it's like xn.b or xn.w or xn.l. Oh, I get it. Okay. That's interesting. Okay. Alright, I can do this. We can do this, guys. The addressing mode requires one extension word that contains the index and extension word. Okay, so this requires an extension word. that contains an index register indicator and an 8-bit displacement. The index register indicator includes size and scale information. In this mode, the operand is in memory. The operand's address is the sum of the address register's contents, the sign extended to displacement of value in the extension word's low order 8 bits, and the index register's sign extended contents, possibly scaled. The user must specify the address register, the displacement, and the index register. Oh, they can also be used as index registers. Oh. These registers are for bit and bit fields 1 to 32 bits, bytes, words, long words, and quad word operations. They can also be used as index registers. Oh, I didn't know that. That's interesting. We have the index register, and then we have the scale. So you multiply it by a scale. These registers can be used as software stack pointers, index registers, or base address registers. Okay. Interesting. All right. Scale 1, 2, 4, or 8. It's 1, 2, 4, 8. Okay. All right. I get this. Uh-huh. Oh yeah. Ba-ba. Da-da. Da-da. Do-do. 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 What's that song from? Oh yeah, it's the weird high school teacher trying to teach his kids French. Haha. Okay. So what's size then? The effective address field specifies the address register containing the address of the operand in memory. After the operand address is used, increment by 1, 2, or 4 depending on the size of the operand, byte, word, or long word, respectively. Coprocessors may support increment for any operand size up to 55 bytes. Okay. Alright. So it seems like the size is either 1, 2, or 4. Same thing. The index register includes size and scale information. In this mode, the operand is memory. Yeah, so this is what we're looking at. xn.size. So the index register, which is a data register or an address register. And then you have the size, and we multiply by the scale. How does the size fit into this? In the scale information, in this mode, the operand is memory. The operand's address is the sum of the address. Oh, by the way, guys. No, fucking never mind. The sign extended is the low order 8 bits, and the index register is sign extended contents, possibly scaled. You know, come on. xn.size times scale. Where does the size come into play here? Unless it doesn't come into play. Unless it doesn't come into play. It could be what's... Oh, I thought I heard a fancy sound somewhere. Sorry. It could be where just like xn... Where it's like d5.b. That's it. It just says the size of the register that it's looking at. That could be it. Oh, no. oh, what if it's like this? What if it's like this? Where it's like, let's say D4 dot B times the scale, which is, I don't know, 2, right? So it's saying D4 has a byte and multiply that by 2. 'Cause scale, from what he read, scale can only be 1, 2, 4, or 8. So that might be it. But then what's the point of saying what the size is? You know, I kind of feel like I'm back learning programming again. It's actually really interesting. It really does. I feel like I'm back relearning programming because of all this stuff, all these little tiny information bits, and that as I'm reading them, I'm finally able to kind of start piecing them together. It's quite interesting, but it's really fun to do. I don't know if fun's the right word. Fun might not be the one right word. I don't want you guys to get fun in your head. It's not fun, it's interesting, and it's engaging. That's where this is engaging, not fun. It is engaging. I wouldn't do this for fun. I enjoy programming, and I enjoy doing this, and I enjoy having viewers to watch and talk with. But I want to do this for fun. There's other things I want to do for fun. The sign extends displayed in value in the extension words low order, and the index registers sign extended contents. So it's just the contents. And then we multiply it by a scale. I think that's it. I think we actually just have what's ever in the data register or the address register, and we just multiply it by a scale value. So if I go like this, Ohio State. Well, we got some from Ohio State, guys. It's actually really cool. We're actually looking at a lot of things based on from like a long time ago. Just .html. Displacement with an index. You don't help me. Okay, so it is just W, wide, long, or byte. Oh, this only has wide and long then, not a byte though. But another register will be added. Scale between 1, 2, or 4, 8. Scale is not supported on device. Not all assemblers will take all listed syntaxes. Yes, I know. Okay. AN. Known as the data register. DN with W. Okay, they don't have byte here for some reason. I don't know why you have to add that, but okay, whatever. You know, maybe when I'm writing the assembler, I'll figure out why I need it. But yeah, I was right. So if we go here, it's just add B, add the byte. We would have an 8 byte, so 16. Oh no, AN. So we'd have A5. Oh no, sorry. Oh my god, we'd have 16. A5. And then XN, So xn would be whatever. So we'd have data register 1 dot. Oh, just get the byte out of there. I get it. Multiply by the scale. So 5, 8. All right, I get it. I can do this. Okay, so we have. I totally get this now. La-di-da. 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 Okay, so number of extension words, 1. Now, wait a goddamn minute here. Okay, hold on. If we go to just number of extension words, 1. So now we have to get into the world of extension words, which have their own wonderful thing. EXTEN. Single effective address operation word format. Okay, brief extension word format. Displacement. I see. So we have the displacement. So the displacement is actually going to go here, and it's going to look like this. Oh my god. Okay. All right. Let's do this shit. So basically, if we have a displacement, we're going to have the 15 bytes for add, and then we're going to have a brief extension word format. Then a brief EXTENSION word, which included the displacement 0, the scale, which in this case is not going to be anything. If W or L. Oh, we can't choose. That's why I only did WL, because we don't choose WL. The register, and then DA. Index register type. If it's word or long word. Oh, that's the index size. Okay. Oh, I get it. Okay. I totally. Oh my god, guys, I get this now. This is great. Okay. So do re mi fa sol la ti do. I get it. Oh my god, guys, it's all coming into play now. Oh god, I'm so excited. I'm really finally starting to understand how these addressing modes work. Guys, I'm excited. Aren't you excited? Alright, so if it's DN, we have no extension words. It's just that, which is cool. Yep, they can do that. When we get to 1... Aha! Displacement. So the displacement always syncs to 32 bits. So basically we're going to have to use a brief extension word format with this because we need to add the displacement. There's no index stuff. So in here, if we just have a brief extension word format, brief, spelled wrong. So if I just have this, we'd have the displacement, which would be 8 bytes. 8 bits. Sorry, not 8 bytes. 8 bits. So if we have the D... If we have the D8... But this also has the index. So what do we do with this? If we have D16? Would we have to use a full extension word format? I think so. Scale... Index register type, yeah, double or long. Scale would be 1, I guess. Base register suppressant. Interesting. Okay. So yeah, we would have. This would include a size. Yeah, so this would have a 16-bit, which number of extension words would be 1, but this would be a full extension word. Effective address specifies plus the sign extended 16-bit displacement integer in the extension word as the operand's address in memory. Displacement is always sign extended 32 bits. But I couldn't use the brief. I'd have to use the full extension. Which would just be... Now, wait a goddamn minute here. Oh, would I just... Okay, I get it. I'm assuming in this case... I just use just the whole entire 16 bits. And then when I get to the index, that's why the index only uses a D8. Because you have all this other wonderful stuff. Okay, so basically... Okay. Getting tired. Okay, so basically, if we have... this, we'd have 16 bits instruction. And then we have the 16-bit displacement. And then if we had this, we would have the brief. So we have the 16-bit. And then we'd have still the brief extension. And it would still be brief because the displacement is only 8 bits. Just fine. Now this... Is this one? Hold on. This is what? BD AN XN dot size dot scale. Does this one... I actually don't think this is used in M68000. Let me check. Yeah, so this is not in the 68,000 software, but so I just have to write these, but I finally understand how this works. All right, guys. So I'm going to end the episode here. What we got done was a tad bit of more stuff. We really kind of figured out how the add instructions are going to work, especially with the effective addresses, and that means like where the other bits are going to go to specify like, oh, you need to add this 16-bit integer to this address register. Figured out what the index registers are. So we all figured out that. Did a lot of reading. Thank you for staying with me. I appreciate it. Yeah. So lurkers who are lurking, thank you so very much for lurking. Watchers who are watching, thank you so very much for watching. Bots who are botting, thank you so very much for botting. These will be up on YouTube in about, I don't know, 1, 2, 3, 4 hours. I'm lazy with this. Yeah, guys, if you're watching this on YouTube, give me a thumbs up if you like what you see. Give me a thumbs down if you hate what you see. In other case, let me know what you hate or don't hate, like about this video, so I know, because I don't know why people are watching this in the first place. I'm glad you're watching it. Thank you very much, especially if you got to the end. Subscribe, that would be great. It's wonderful because it tells me that you know that learning's hard, and that's fine. What else? If you're watching this on Twitch, guys, give me a follow, because that is also pretty fucking awesome. But yeah, everyone, if you want, you guys can see me tomorrow on my gaming channel. I'll be gaming from 8 to 9:30 in the morning tomorrow, doing some Legend of Legaia, beating the final boss, watching the credits, and going to my next game. So yeah, catch me on Active Fireball, or just follow me on YouTube. Alright, everyone, I love you all, and I will see you all tomorrow or next week.